Hey guys, and welcome back to another episode of Likanayan. Again, it's Jana, and today joining me naman is Victor.
Hello! Kung bago nyo pala panoorin tong video na to, be sure to consider checking out our previous episodes too. Link down below in the description. Maganda sila.
For Lika Kwentuhan naman later, it's going to be a little different kasi walang cam yung guest natin for today. But she more than makes up for it in insight naman. So let's definitely catch that later.
Mysterious. Okay, anyway, kaway-kaway muna sa inyo because our topic for today is waves.
Uy, hindi to yung waves na kaway ah.
Siyempre hindi. Today we're going to talk about sine waves. Well, hindi lang yon, pero lahat kasi yung i-discuss natin today may kinalaman sa sine and cosine waves, both of which are called sine waves.
Okay, so ayun na nga. Like Victor said, we'll be discussing sinusoidal waves. Pero first of all, ano nga ba yung sinusoidal waves? Na-mention na that sine and cosine are sine waves. Pero what else?
Well, basically, it's a curve that follows the graph of the sine function. Meron siyang peaks and troughs at a consistent maxima and minima, called the amplitude. Sa sine at cosine, this is 1 and negative 1 respectively. Kasi kahit anong input na x value, hindi natataas or bababa yung y value sa dalawang to. Each peak is also separated by a constant interval. Tapos pareho rin yung interval na to for the troughs. This is called the wavelength. For sine and cosine, it's a difference of 2 pi between one peak or trough and the next.
Marami ring uses ang sinusoidal functions sa physics. The first, for sure, familiar na kayo. It's used to find the x and y components of a vector. Diba, cosine for x and sine for y. Applicable rin siya, syempre, for angular quantities, like with oscillation and rotational motion. Kasi instead of displacement, you're dealing with changes in the angle. Last but not the least, igagamit rin to sa electromagnetics, since electric and magnetic fields have to be perpendicular to the object or plane.
Now let's talk more specifically naman about the oscillation. This is also called periodic motion kasi yung gumagalaw na thing, bumabalik-balik lang siya after a set amount of time. Like yung swing na electric fan. One kind of periodic motion is simple harmonic motion, which happens when there's a restoring force that brings the thing to and from equilibrium.
Simple harmonic motion, or SHM for short, can be modeled after a sine wave, of course, and x of t is equal to a sine of omega times t plus phi. A is yung amplitude, omega is yung angular frequency, which is angular displacement per unit time. Pwedeng ma-express din siya in terms of period or frequency, or pwede rin in terms of mass and spring constant k. Next, t stands for time in seconds, and phi is whatever angular position the object may have had at t equals 0.
There is also such a thing called angular SHM, which is for rotating objects, parang steering wheel na bumabalik-balik lang. This has some new quantities that are roughly equivalent naman to the ones we already know. Torque is what replaces force, or yung restoring force. Moment of inertia replaces mass. Tapos meron din namang equations online to find the moment of inertia for anything. And finally, we have kappa, or the torsion constant, which replaces the strain constant. Madali na maalala yung last na yun kasi kappa just looks like a K2.
Lastly, for oscillations, we have pendulums also. This one actually does not undergo SHM kasi the restoring force for pendulums is gravity. This means na mayroong radial component na parallel sa radius, which just pulls the pendulum outwards, which we don't want. Meron din namang tangential component, which is the one that actually pulls the pendulum to the equilibrium point. So we do want this one. This means that the torque is no longer simply directly proportional to theta, but instead to sine theta. Kasi nga, doon siya sa component related. However, pag maliit naman masyado yung theta, we can simplify sine theta to just theta, so it works out.
Next naman, we have a more calculus application of sinusoidal waves, which is the wave equation. This equation can describe classical waves, so water waves, sound waves, even light waves, using a calculus relation. Nagsisimula siya sa wave function, which is y is a function of x and t, equals a times cosine of k x minus omega t. Tama. 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 Kung mapapansin nyo, dalawa yung pwedeng input. We'll get to that in a bit.
Okay, so yung wave equation is a second order partial differential equation. But obviously, none of those words make sense. So let's break it down from here. Second order simply means you've differentiated twice. So nag-d over dx ka twice. Partial differential equation, or PDE, is an equation that relates the partial derivatives of a multivariable function. Again, what do those words even mean? A multivariable function is like our wave function. More than one yung input variable niya. A partial derivative naman is a derivative na dinifferentiate mo using only one of the input variables. So TLDR, this means that the wave equation relates the second derivative of position and the second derivative of time to each other, both of them coming from the wave function.
Lastly, sa electromagnetics naman, meron tayong two laws na gumagamit ng sinusoidal waves, gas law and Ampere's law. Gas law is used to calculate electric fields passing through a surface or an object. It relates electric flux through a Gaussian surface to the net charge enclosed within. Okay, hinga. Ulit, pero this time with explanation. Your electric flux is the flow rate of an electric field through a given area. Yung given area naman natin in this case is the Gaussian surface, which is enclosed surface in 3D space. Basically, para siyang ping pong ball, I guess. Like, it's pretty much just a closed-off surface, ganun. Yung charge enclosed naman is just the total charge na nasa loob ng Gaussian surface. Parang yung hangin sa loob ng bola.
So with the help of Gauss's law, pwede mo mahanap yung electric field ng point charge through a conductor, through spheres, and even in infinitely long lines of charge, and also infinite planes of charge.
Very, very, very last, meron din naman tayong Ampere's law na para naman sa paghahanap ng magnetic field. It relates the integrated magnetic field around an Amperian loop to the electrical current passing through the loop.
Ampere's law involves calculus. Well, actually, so does Gauss's law, pero mas straight up kasi tong sa Ampere's law. Yung integrated magnetic field is quite literally that. Makukuha mo pag integrate mo yung magnetic field.
An Amperian loop naman, much like Gaussian surface, is a closed and imagined loop whose plane is perpendicular and centered to the wire where the current is flowing through. Parang if you poke a hole through a paper gamit ng isang lapis, tapos nakasenter yung lapis sa papel, yung lapis yung wire or source ng current mo, tapos yung papel yung loop. Also, papers are rectangular, ano? So in line with this, yung loop mo is not necessarily a circle or an oval. Pwede rin naman siya maging rectangle.
Kung nagtataka nga pala kayo kung anong relate ng sine and cosine sa dalawang laws na yun, well, simply put, dapat kasi perpendicular yung fields mo sa surface. So at some point, you will have to use cosine to straighten it out. Actually, medyo yun lang naman yun. Kasi pagdating sa dulo, pag na-derive mo na yung mismong equation for the two laws, nawawala na yung cosine. So actually, they kind of involve a little more calculus and equation massaging than sine waves. Pero, okay lang yun. Importante pa rin naman siya.
Ayan, huwag na kayo magtaka because that is the end of discussion. Punta naman tayo sa Lika Kwentuhan. Let's talk a little bit more about all this conceptual physics. Yak! Hi guys and welcome to Lika Kwentuhan, the segment in Likanayan where we introduce PSI alumni and PSI teachers and ask them about their physics lives.
For the 6th episode, let's welcome Pia Feliciano from Batch 2019, who is now currently studying in UP Diliman, taking up BS Physics. Yay! Thank you so much for agreeing to be our guest for this episode.
Happy to be here, guys.
Before we ask our more serious questions, let's start off muna with the first one, which is, please introduce yourself and tell us about what you're doing right now.
So right now, I'm a sophomore sa UP Diliman, BS Physics, as you said. I'm in my second sem. Actually, parang ngayon pa lang nagka-catch up yung mga lessons from SYP. Like right now, yung lesson that we're supposed to be learning is special relativity for my majors. So that's just like a small portion of the curriculum naman. So yun, wala naman. Wala din masyadong makikwento kasi ano naman i-share kasi yun yung syllabus ko.
Okay, so since hindi mo
Oh my
naman
God.
sure yung syllabus, tell us na lang why you chose this major and meron ka bang future plans in the field? Like, you chose this major because you want this job, ganon, or is it something else?
That's a good question. Sir Vinny, kung pinapanood mo tong video ngayon. So, actually, nung pumasok ako ng Pisay, I wanted to take psych pagdating ng college kasi gusto maging psychiatrist. Pero, during grade 7, I found out na hindi pa accepted as a course from Pisay yung BS Psychology. So, inisip ko, sige, I'll just start liking a science para doon na lang ako pupunta. So, physics yung tumugma. And eventually, by the time na approved na yung BS Psych, which was around my 4th year in Pisay, I liked physics enough that I chose it over Psych na. So, honestly, like, Pisay is so lucky because sobrang galing ng mga physics teachers doon. And you can quote me on that. Like, yung physics teachers natin sa Pisay, they're the people who really got me into physics. Like, si Ma'am Bonnie, Sir Jalvarez, Sir Ken, and Sir Vinny. Silang lahat na kuha ko yung physics under them and I was very inspired to take up physics after. Lalo na yung Sir Vinny kasi sobrang laking nerd ni Sir Vinny eh.
Cute.
So, yun, for the future, sana makapag-research ako, of course. Planning to take a postgrad then after my undergrad and then maybe a PhD in the future, but we'll never know.
Yes, naman. That's so cute. Do you actually use high school physics in college? And does the Pisay advantage exist in this aspect? So, yung mga physics 9, 10, 11, and 12, na-apply ba natin sa college?
Okay, that's a good question. Honestly, yes. Siyempre, nakakatulong talaga yung high school background on physics. Especially with like entrance exams. Not even like college mismo, like pagdating sa entrance exams, like having that the background sa science and math really helped me. So talagang lahat naman ng lessons are very helpful in college, especially since yung Pisay curriculum medyo advanced siya. That's how Pisay is marketed. The curriculum's advanced. So, yun nga, ngayon pa lang nakakapag-catch up sa SYP lessons yung lessons ko ngayon sa majors ko. And I'm already a year and a half in. And pagdating dun sa math, yung parang basic na series ng math once you start going to UP, most of it is stuff we've already learned in high school, just applied differently or taken a step further, may extension, yun. But then, other than that, like, yung foundation that Pisay has given is good. But then, at the end of the day, I don't think it could be said that it's a Pisay advantage because ganun din naman, mag-aaral ka pa rin because you have to learn how the profs want you to answer certain things, how you should answer certain problems, how you approach tests, mga ganun. So, it's a lot of relearning din. Yung Pisay advantage, I think, yung pinaka-advantage that we have is that pag pumasok tayo sa UP, sanay na tayo bumagsak.
I expected that answer. I love it.
Because it's true. Like, hindi naman advantage na alam mo yung mga inaaral nyo because it's not like you can skip through it unless yung parang placement exam, you can take one of those para you don't have to take certain courses anymore. Pero yun nga, it's not that big of an advantage. The biggest advantage is really like being used to a high pressure environment and sanay tayo mag-cram, sanay tayo mag-all-nighter, mga ganun.
It's a mental and emotional advantage. Academic.
So, speaking of the Pisay advantage that, according to you, doesn't really apply to the actual physics lessons, what's the most important thing then that you took from high school into college?
I think the best thing that I learned in high school that I brought into UP that I'm still using right now is that try to enjoy as much as you can without failing your classes. Because, yun nga, parang when you fail a class kasi you have to retake it or madedelay ka and all that it's a whole hassle. So, if you can at least pass your classes, mag-enjoy ka na. Like, have a good time while you're at it. Because for a lot of people, if you ask most adults, they would say that college was a really big time for them. Na it was a place that they enjoyed. And if you pressure yourself into getting good grades just because gusto mo mag-laude or whatever, nawawala yung enjoyment eh.
Oh, gusto ko tayo maglakwa. Gusto na mag-try no, ma.
So speaking of fun, what's the most fun thing or the coolest thing that you've learned as a physics college student?
Actually, nung nakita ko tong tanong na to, hindi ko rin alam kung paano ko sasagutin. Because honestly, like, wala naman akong natututunang bago masyado. Mostly like new things sa math, and now I'm learning more in-depth things about physics, but other than that, wala naman masyado. Pero yun nga, like the fun is in learning these things and the challenges na nafe-face mo in learning them. Tapos parang the frustration na pag hindi mo maintindihan to, you walk away from it for like a few hours and then you come back and then you're like, sige, let's try this again. And then you finally figure out, and that's what's fun, the satisfaction you get after figuring it out, knowing that you put so much effort into it.
That's so cool. Sobrang relatable nun. So, for our second to last question, was physics fun? What are the challenges na kailangan yung i-face during physics in high school? At paano tong mga challenges na to, paano sila naka-affect sa'yo in college?
Thank you for that question.
You're welcome.
Never pa talaga tayo nag-reply, no? Sige na nga, ito na.
I'd say that physics is fun. And I think a lot of people can easily enjoy certain kinds of physics, like astronomy, there's a kind of physics for everybody, I believe. Like, there's a type of physics that any person will find interest in. Honestly, like, physics as a course, as a major, it's very math heavy. And honestly, like, I'm not the sharpest tool in the shed. Pag tinignan mo yung grades ko sa Pisay, tawa na lang tayo. So, yun nga, I'm not very good at math, but it's something I enjoy. And I think, like, for any aspiring physics majors, like, they should be willing to take on the challenges that come along with being a physics major. Because sometimes it's not even the math that's hard. Sometimes it's just the concepts. Like, it's so hard to wrap your head around them. There's stuff that you can't even fathom na nakalagay sa module mo, and you have to read through it like 10 times for you to understand it. And if you're willing to take up that challenge, like, it helps make physics fun talaga eh. So yun.
Wait, last question. Wala to dun sa list, pero na-curious lang ako. Would you say na like sobrang laki ng difference between like pre-COVID and COVID? Like taking up physics, is it harder na modules lang? Or like malaking difference ba for you? And nahirapan ka ba?
Honestly, like, there is a huge difference. Pero you can't really take it from me kasi for me, the struggle with face-to-face classes sa UP is nakakatamad pumasok sa klase. That's actually like one of the biggest challenges for me. I find it hard to go to my classes regularly kasi dealing with like mental health stuff, I find it hard to motivate myself to come to class, lalo na magkakalayo pa yung buildings ng classes ko, ganon. But then ngayong pandemic, my class is just on my laptop. I don't even have to like commute to school. I don't even have to take a shower to go to class. So there are like advantages to it, although there are disadvantages to take into account. There are caveats na, for example, mayroong mga prof na hindi nagpapa-lecture ngayong pandemic because it's hard to put out lectures because some people don't have access to internet. But yung modes of like assessment, iba na eh. A lot of classes sa physics hindi nagpapa-exam. So magpapasa kami ng prob sets, ganun. Magbabasa ng modules. So yun.
So that is for our Lika Kwentuhan. Thank you so much, Pia, for joining our Likanayan. Thank you dahil meron kang time to join us. We know napaka-strict ng schedule mo. We know na napakarami mo kailangan gawin.
Thank you for having me. I appreciate it.
So that is it for our Lika Kwentuhan, and that's the end of episode 6 of Likanayan. Thank you so much for watching our video, and I hope you enjoyed. Stay tuned for our last episode 7 of Likanayan. Bye-bye!
Bye!
Bye!
Bye.